You're looking at a few graphical motion questions. Try them, get answers, and then come on back for the answers and explanations. Okay, let's take a look at these. First of all, position of a position time graph means distance or displacement. And since we're dealing with negative acceleration, we have an object that's slowing down. If we have slowing down on a d versus t graph, that's going to be a curve. And what's happening is we're going from some velocity to essentially a zero velocity. So it's got to be choice 2. Can't be choice 1 or choice 3, because that would be constant velocity, which means acceleration would be 0. And choice 4, we would be going from essentially a 0 velocity to some value for velocity, so it would not be negative acceleration. So the only choice it can be there is choice 2. If we take a look at the graph to the right, we have speed versus time. With a v versus t graph, the slope always represents a, which is acceleration. So that's what it's asking for, what quantity is represented by the slope. Now, if you were asked to calculate the slope, it would be the change in y over the change in x is always slope. So what the change would be, it would be 4 minus 0, or 4 meters per second over 3 seconds. And of course, 4 divided by 3, it would have been 1.33, or 1.3 meters per second squared. The question didn't ask that. It just asked for the quantity, but you have to know how to calculate slope. For the distance, that's the area underneath the curve on a v versus t graph. So since the shape is a triangle, I'm just using 1/2 the base times the height. And since I'm showing all my work, including equation with substitution with units, you have to have everything. You have to have the equation, you have to have the substitution with units, and you have to have the answer with units. Now, when it comes to graphical motion, there's always 9 graphs I ask my students to memorize and make sure they have it to make these kinds of questions easier. And here are some graphs, not the greatest, but let's take a look. This first one, or these first 3, would be for an object at rest. The next 3 would be a constant speed or velocity, and the last 3 for a changing speed or velocity. D versus T, V versus T, A versus T. At rest, the distance or displacement, it's a horizontal line over time. Of course, if I have an object at rest, it's 0 velocity and 0 acceleration. For constant velocity, for D versus T graph, D versus T, V versus T, and A versus T. For my D versus T, it's a diagonal line, because of course the slope of a D versus T always gives me V. My V versus T is going to be a horizontal line, and my A versus T is still going to be on the 0. It's 0. And then for changing velocity, D versus T, V versus T, and A versus T. For a D versus T graph, that's where we get a curve, because of course the slope is changing. V versus T, diagonal, and A versus T is going to be some value. Now we can have, negative and going towards, the starting position away, negative velocity versus positive velocity, but these are just the basic graphs. Now, don't just know the graphs. Know for a D versus T graph, the slope will give you V. For a V versus T graph, the slope will give you A, and the area underneath the section of the graph will give you D. And that's why a lot of times Regents questions love to ask V versus T questions, because they can ask about velocity, they can ask about acceleration, they can ask about distance or displacement. So make sure you know this basic information to be able to answer questions like this easier. Keep working hard, and good luck.